Picture this, a satellite floating high above Earth doing its job, until suddenly electrical surges knock it out of commission. Sounds like something straight out of a science fiction movie, right? But it's a real issue that's been affecting satellites for decades. And now, scientists have finally uncovered the cause. Let's dive into how space weather might be sabotaging your communications and GPS systems, and what's being done to stop it. Back in 1994, two Canadian TV satellites, Anik E1 and E2, failed within hours of each other. They were orbiting Earth when a solar storm hit, causing an electrostatic discharge. This discharge messed with their control electronics, knocking them out of service. This wasn't a one-off incident. Similar failures have been recorded in recent decades, and scientists have been working hard to figure out why. The problem is caused by what's known as spacecraft environment discharge, or SED. Basically, satellites in space can accumulate electric charges over time. These charges build up because of the charged particles bombarding the spacecraft from all directions, mainly from the sun but also from Earth's ionosphere. When different parts of the spacecraft reach different voltages, it causes sparks, electromagnetic interference, and even transient currents, which can fry the electronics. To solve this puzzle, researchers from Los Alamos National Laboratory placed sensors aboard the Space Test Program's Satellite 6, STP-Sat6. These sensors measured the spacecraft's electrical environment and the surrounding electron activity in space. After more than a year of data, the researchers made an important discovery. There is a direct correlation between surges in electrical charge on satellites and peaks in electron activity in space. Here's how it works. Electron activity in space tends to peak 24 to 45 minutes before a discharge of electrical currents happens on a satellite. It's like the electrons charge up the satellite before the discharge occurs. The research shows that as electron activity increases, the spacecraft starts to accumulate charge until a tipping point is reached, causing the SEDs, and this pattern can be measured ahead of time. So what does this mean for future satellite designs? Well, knowing that there's a predictable window of time between electron activity and electrical discharge opens up the possibility for forecasting tools. These tools could warn satellite operators before a discharge happens, helping them take preventive action. This would be a game changer in minimizing satellite failures caused by this phenomenon. Space weather, driven by solar flares and solar wind, isn't just an inconvenience, it's a growing problem. The more we rely on satellites for communications, weather forecasting, and even GPS, the more important it is to understand how this electrical discharge can impact their performance. We could see these surges becoming more frequent as solar activity increases, especially with the upcoming solar maximum. With these new findings, satellite manufacturers are already looking at ways to shield spacecraft from these harmful electrical surges. From better grounding systems to materials that dissipate electrical charges, the future of satellite design will be all about adapting to the harsh conditions of space. Scientists hope that this research will help reduce the costly damage caused by these electrical surges and ensure our satellites keep working in orbit for years to come. What do you think about the dangers of space weather on satellites? Could forecasting tools be the key to protecting these high-tech machines? Let us know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon to stay updated on the latest breakthroughs in space science. Thanks for watching, and we'll see you in the next one.